For over a decade, rumors swirled that Mercedes-Benz was working on something that could completely upend electric vehicle performance. Now it's official. The YASA Flux motor, a disc-shaped engine barely larger than a pizza, is real, in production, and ready to power AMG's electric future.
But this isn't just another motor, it's a rethinking of EV drivetrains from the electrons up. It delivers more torque, takes up less space, runs cooler, lasts longer, and opens up new possibilities for how cars are built. And it all started with a frustrated student and a single stubborn question.
Back in 2009, Tim Woolmer, a doctoral candidate at Oxford, stared down the limitations of radial flux motors, heavy, wasteful, and stuck in the past. He asked, why should magnetic field lines take the long way around a motor? What if they could go straight through?
That late-night question became a sketch. That sketch led to a prototype, and that prototype birthed YASA Limited. Fast forward to today, and that flat axial flux motor made from segmented yokeless sliceless bonded with epoxy is locked into AMG's production lines. Weighing just 25 kilograms, this motor delivers a constant 200 kilowatts with peak bursts hitting 350 kilowatts. That's supercar power and something you could lift in one hand. But the real magic isn't just raw power. Traditional radial motors trap heat deep inside thick cores, which means power has to drop off before things melt down. YASA's design solves that at the root. Oil flows through microchannels in the copper wirings, cooling the motor where heat is born. This keeps the system stable even under full load and eliminates the need for sudden performance cutoffs. This same oil also lubricates the twin ceramic bearings, removing the need for grease and stretching the service interval to 250 kilometers. And because the motor is only 80 millimeters tall, Mercedes can now put it where radial motors never fit, between the crank and the gearbox, under the seat, or even inside a wheel hub. That packaging flexibility led Mercedes to create an entirely new vehicle architecture, the AMG EA platform. How it works. Instead of cramming modern tech into old gasoline skeletons, AMG EA is a clean state built around YASA's ultra-thin, high-powered motors. By dropping the floor, eliminating the prop shaft tunnel, and reducing bulk, Mercedes unlocked more interior space, better aerodynamics, and cleaner weight distribution. And in real-world testing, this meant dropping the battery by 18 centimeters, cutting 200 kilograms, and granting 2/10 in a slalom test. Okay, let's now talk about torque. Each YASA motor delivers 800 Newton-meters, and because its axial torque arrives with almost zero rotational inertia, there's just no delay. There's less gyroscopic drag, steering becomes more immediate, grip feels surgical, and, because of all this, test drivers describe it as a braided cable straight to the tire. And it's not just about performance. This design enhances sustainability too. Epoxy waste from the production line gets reused as sound insulation in other vehicles. The plants are solar-powered, rainwater cools the machinery, and every motor is traceable with a digital birth certificate tied to the exact batch of copper used. The production itself is a masterclass in precision. Inside Yanton and Berlin's factories, robotic arms handle the delicate work. Copper ribbons are laid into segmented stations without human hands, and resin floods every gap. Then, infrared lamps cure the entire unit in under 2 minutes. 6 access laser channels check for even the thinnest of misalignments, and if a weld deviates by more than 50 microns, production stops. And the unbelievable thing is, Mercedes didn't just stop at building this motor. No, they went ahead and built the whole ecosystem around it. A new battery chemistry, borrowed from Formula One, delivers 350 kilowatts of regenerative braking. Plus, a shared oil circuit cools not just the motors, but the inverters and gearbox too. This clever design cuts weight, improves thermal efficiency, and lets the battery warm up faster on those chilly mornings. Or, stay cool during fast charging. Their new AMG C590, which is entering pre-series production this fall, uses 4 of these motors. That's 1 per wheel, each paired with its own inverter and 2-speed gearbox. The total output, over 400 kilowatts. And yet, this setup is 90 kilograms lighter than the outgoing V8 hybrid system. Can you even believe that? Validation wasn't just numbers on paper. Nope, Mercedes clocked over 1.6 million kilometers. In real-world testing, they ran 4,000 launch control starts, 1,200 fast chargers, and heat cycles up to 43 degrees Celsius in the Spanish deserts. And not a single motor failed. No cracks, no bearing wear, no heat-related derating, nothing at all. On the Nürburgring, prototype cars lapped over 80 times at full output with zero drop-off. Inside the factories, the process is just as refined. Epoxy-coated floors guide silent autonomous carts, and every station segment is vacuum-impregnated, cured, and tested in minutes. Rotor stator clearances hover with 150 microns across a 400mm span, and blue light metrology confirms it. Each unit gets a digital ID syncing back to the real-time dashboards. This basically means that a vibration in Oxford gets corrected in Berlin before lunch. Cooling also isn't just efficient, it's clever. A honeycomb of microchannels inside the stator floods the copper with biodegradable dielectric oil. The same oil lubricates bearings and helps chill the inverter. And this results in sustained output at 200 kilowatts, even in a 38-degree Celsius ambient. And when pushed to 350 kilowatts for 20 seconds in qualifying mode, the oil temperature rises just 4 degrees.
Now what does this mean downstream? Well, smaller radiators, shorter hoses, less heat soak, which essentially results in longer battery life, faster charging, and much improved safety in cold climates. It also gives a 5% range bump by pre-warming cells. And it lowers insurance costs too. Shorter braking distances, fewer claims, better crumple zone, all thanks to smaller, lighter motors.
And on cost, Mercedes expects each motor gearbox inverter unit to hit under €3,500 at scale. That's less than their current combustion setup and, honestly, dramatically more effective. With a peak power density of 16 kilowatts per kilogram, it actually beats Tesla, Porsche, and even Rimac on practical performance metrics. WLTP ratings show 93% average efficiency and 96% at peak. Energy draw in city traffic slips under 18 kilowatt-hours per 100 kilometers, which means that a 100 kilowatt-hour battery delivers 650 kilometers of range. Even the smaller 80 kilowatt-hour version clears 520 kilometers, and when it's time to recharge, 350 kilowatt fast charging adds 250 kilometers in just 7 minutes. And the thing is, Mercedes didn't just design a motor, they redefined their entire EV approach, probably revolutionized EVs as a whole. By starting from scratch, they created a modular platform that scales across sedans, SUVs, and coupes. And the next AMG Halo Coupe arrives in 2026. A performance SUV lands in 2027, and a China-focused liftback follows in 2028. All share 80% of the same underbody structure, all use YASA's motor.
Inside, the benefits are clear. No driveshaft tunnel means more legroom, better dashboard design, and a lower floor. Wider suspension arms improve handling, and lighter weight increases range. Even seatbelt anchors are better integrated. And it's not just more efficient, it's more livable.
And, the funny thing is, it might not even stop at the road. Daimler's partner Ivalo is actually testing a version of the YASA motor for aviation. At 10 kilowatts per kilogram, it's just ideal for a vertical takeoff aircraft. Same factory, same automation, but now a whole new market. This could really redefine mobility both on the ground and, up in the sky. And Mercedes has poured hundreds of millions into this vision. For example, solar roofs actually power the factories. Eoxy waste gets reused, and rainwater gets recycled. Training programs ensure that 40% of new hirees are apprentices, keeping human expertise totally in sync with the machines. This is precision engineering that's built to scale, evolve, and honestly, last. Now, everything points to one idea. Mercedes isn't chasing trends, they're setting the benchmark. The YASA Flux motor isn't just clever design, it's a new foundation, a complete re-architecting of what electric propulsion can be, built not upon incremental improvements but on a fundamental reimagining of electromagnetic principles. And it all began with one frustrated student and a stubborn question, a moment of intellectual defiance against the accepted norms of engineering that would eventually ripple through the entire automotive industry. The original sketch, that first visual manifestation of a radical idea, it still hangs outside Tim Walmer's office in a simple frame, a sacred piece of corporate lore. And every AMG engineer passes it on the way to the CAD stations, a daily pilgrimage that reinforces the culture of innovation. Now this is not a nostalgic relic, not merely a tribute to a past breakthrough. It is a challenge, a perpetual gauntlet thrown down to the brightest minds in the field, a reminder that physics always has room to negotiate, that the laws of nature are not constraints but invitations to find a more elegant solution. And innovation begins, where assumptions end, where comfortable conventions are questioned, because sometimes to leap forward, to make a genuine breakthrough that changes the landscape, You just need to take the shortest path, to bypass the long and winding road of tradition, and go straight for the elegant, direct solution.
And if you found this interesting, this story of how a single query whispered in a late-night lab can evolve through years of unwavering dedication and precision engineering into a full-blown technological paradigm shift that fundamentally redefines our understanding of performance, sustainability, and design, then we invite you to become a part of our community of the curious. Consider subscribing for more quiet, revolutionary stories like this one, where we pull back the curtain on the breakthroughs that don't always make the front page but are nonetheless relentlessly shaping our future. These are the tales of under-the-radar advancements, the elegant physics and unsung engineering marvels that operate beneath the surface of mainstream buzz, which are subtly but profoundly reshaping our world, one innovation at a time.